First we'll see that today what we'll learn today. There's 2 points to describe the general characteristics of solid state and to distinguish between amorphous and crystalline solids. First, we'll come with introduction. We know nowadays the carbon nanotubes is the new materials and it has potential to be stronger than the steel but lighter. That means weight is less than aluminium and more conductive property than copper. So that is why we learn the solid state. Such materials play an expanding role in future development of science and society. Some other materials which are expected to play an important role is the high temperature semiconductor, magnetic material, biodegradable polymers for packaging, biocompliant solids for surgical implants, and thus the study of this solid state becomes more important in the present scenario. Now, formation of the solid state. The constituent particles in solids have fixed position. We know that is the one reason why it is called the solid and can only oscillate about their mean position. This explains how much rigid the solid. And these properties depend on the nature of the constituent particles and the binding force. That means these properties of the solid, that means rigidity and oscillation about their mean positions, is due to the 2 factors. One is the nature of the constituent particles and second is the binding force operating between these particles. The correlation between structure and properties helps in the discovery of new solid materials with desired properties. Now, the characteristics, properties of the solid state. They have definite mass, they have volume, and they have shape. Intermolecular distance are short. That means the distance between the 2 molecules is short. Intermolecular forces are strong. That means force between 2 molecules are very strong. Their constituent particles, that means atoms, molecules or ions, have fixed position and can only oscillate about their mean position. This is the characteristics of the solid. Just now whatever I told. They are incompressible and rigid. Now, amorphous and crystalline solids. Solids are classified by 2 terms, crystalline solids and amorphous solids, on the basis of the nature of order present in the arrangement of the constituent particles. That means whatever the arrangement of the particles, whatever atoms, molecules or ions, whatever it be in the solid, into the pattern of the order of the arrangement depends on that solid will be crystalline or amorphous. A crystalline solid usually consists of a large number of small crystals. Here we have to remember this, that crystalline solids is made up of a large number of small crystals, and each of them having a definite characteristic geometric shape. That means each small crystal has definite geometrical shape. The arrangement of constituent particles, that means atoms, molecules, or ions in a crystal is ordered. We have to remember, it should not be disordered. It will be in ordered form. That's why it has that definite geometrical shape and repetitive in 3 dimensions. If we observe the pattern in one region of the crystal, we can predict accurately the position of the particle in other region of the crystal. However, for they may be from the place of observation. That means we know the one pattern of a small crystal at one position of the solid, crystalline solids, then we can predict the pattern of the other crystal in the different region or the other regions. Now, amorphous and crystals. Crystal has a long range order, which means that there is a regular pattern of arrangement which repeats itself periodically over the entire crystal. Later we will see the figure, then you will get the clear picture of it. So example, the sodium chloride and quartz is the example of the crystalline solids. On the other hand, the glass, rubber, or many plastics do not form crystals. When their liquid solidify on cooling. That means glass, rubber, and many other plastics, from the liquid we have to cool to make it solid, and it do not form any crystals. That's why it has another name, amorphous solids. Now you can see the term, how the amorphous solid has come. The amorphous means that no form. It is the Greek word. That means amorphous means no form. The arrangement of the constituent particles, that means atoms, molecules, or ions in such solid, has only short range order. It doesn't have the long range order like the crystalline solids. Now we will see the figure. Here, 2 different picture is there, picture number A and picture number B. Picture number A for the quartz, that means crystalline solids, and crystalline B is the quartz glass. So here it is written there, you see the structure of the quartz, that means which is crystalline, and the quartz glass, which is the amorphous. This is the crystalline characteristics and this is the amorphous characteristics. And you can see that it has that order and long range. If you come from here to here also, you get the definite pattern. And that's why it is the crystalline solid. On the other hand, this picture number B, you see that this doesn't have the order in the long range. From here, what is the order is there, here it is different, here it is different. So that's why it is called the amorphous. Crystalline solids have a sharp melting point at a characteristic temperature. They melt abruptly and become liquid. And with this property, we usually distinguish the organic material from other organic material in respect of the melting points. On the other hand, the amorphous solids softens, melts, starts flowing over a range of temperature. You see that for crystalline solid in a characteristic temperature, at a definite temperature, but the amorphous solids melt over a range of temperature and can be molded and blown into various shapes. Amorphous solids have the same structural features as liquids and are conveniently regarded as extremely viscous liquids. That means amorphous solids also used to call as extremely viscous liquids. They may become crystalline at some temperature. Some glass objects from ancient civilization are found to become milky in appearance because of some crystallization. Like liquid, amorphous solids have a tendency to flow through very slowly. That means amorphous solid has the characteristics of liquid to move or to flow very slowly. Therefore, sometimes these amorphous solids are called pseudo-solid or supercooled liquids also. Amorphous solids is isotopic in nature. Their properties such as mechanical strength, refractive index, and electrical conductivity, etc. are same in all directions. That's why it is called the isotopic in nature, amorphous solids. It is because there is no long range order in them, whatever we have seen in the figure. An arrangement of particles is not definite along all directions. Hence, the overall arrangement becomes equivalent to all directions, and therefore the value of any physical property would be same in all directions, along all directions. Now you can see this picture. You can see that different arrangement of particles around different direction. You see that if you put this straight line into sides, and every place you can see the different type of arrangement of the particles. And this is the characteristics of the amorphous solids. So now we'll see the difference in property between the crystalline solids and amorphous solids. If you consider the shape, then in this case crystalline solids are definite characteristic geometrical shape, but for amorphous solid, irregular shape. If you consider the property melting point, whatever just now I discussed, that melt at sharp and characteristic temperature, but gradually for amorphous solids, gradually soften over range of temperature. If you consider another property, the cleavage properties. For the crystalline solids, when cut with a sharp edge tools, they split into two pieces, and the newly generated surfaces are plain and smooth. But if you see the amorphous solids, as for example, very example is the glass. When cut with the sharp edge tools, they cut into two pieces with irregular surface. Now another property will consider heat of fusion. For the crystalline solids, they have a definite characteristics enthalpy of fusion. This enthalpy term you already know from the class 11 syllabus. But for amorphous solids, they do not have definite enthalpy of fusion. Anisotropy. Crystalline solids are anisotropic in nature, but for amorphous solids, the isotropic in nature. Another property is the nature. Nature means the crystalline solids is the true solids, but amorphous solids, its nature is the pseudo solids or supercooled solids. Now last property, order in arrangement of constituent particles. For crystalline solids, long range order, but for amorphous solids, only short range order. So this is the difference between the crystalline solids and amorphous solids in respect of their properties. I hope that you understood clearly what is the solids and what types of solids are there, what is crystalline solids, what is the amorphous solids, and what is their property difference. Now, besides crystalline and amorphous solids, there are some solids which apparently appear amorphous but have microcrystalline structure. That means in between. These are called the polycrystalline solids. Metals often occur in polycrystalline condition. Individual crystals are randomly oriented, so a metallic sample may appear to be isotropic even though a single crystal is anisotropic. I think you understood very clearly from my previous discussion, anisotropic and isotropic. Solids are useful material, that is glass, rubber, plastic, find many applications in our daily lives. Amorphous silicon is one of best photovoltaic material available for the conversion of the sunlight into the electricity. That means for the solar electricity, this amorphous silicons has enormous use to make the polyvoltaic materials.